In this lesson, we will discuss the creation and use of clusters to group data of mixed types. First, let's define what a cluster is and identify the main reasons to use clusters. A cluster allows you to combine related data elements of different types into a single data type. Here we see a cluster that combines information that all relates to weather data. A cluster is functionally similar to a record or a struct in text-based programming languages. Most clusters on the diagram have a pink wire and data type terminal. It is still possible to access the individual data elements that are stored within a cluster. Clusters and arrays are similar in that you can use both to collect related data into a single data type. There are two key differences between these data types. Clusters allow you to combine data of different types, whereas an array can only contain one data type. Clusters contain the number of elements that you add when you create the cluster. The number of elements in an array can be programmatically modified at any time. Now that we understand what a cluster is, let's discuss why you should use them. Clusters help to improve data organization both on your panel and on your diagram. On the panel, the cluster ensures that you never accidentally separate related controls or indicators. The cluster border visually indicates that these items are related to each other. On the diagram, instead of having separate terminals for each data element, the cluster is shown as a single terminal. This enables you to keep the data together when passing it into other VIs on your diagram. Clusters that only contain numeric values have a brown wire and data type terminal. You can wire brown numeric clusters into numeric functions to perform the same operation simultaneously on all elements of the cluster. Bundling several data elements into clusters eliminates wire clutter on the diagram and reduces inputs and outputs for your sub-VIs. Now that you know why you should use clusters, we will discuss how to create them on your panels and diagrams. Now let's explore the creation of clusters on our panel and diagram. We'll begin by creating a cluster control. First, we'll create an empty cluster. Now we'll add several data elements. Now let's create a cluster constant on our diagram. To do this, we can either create it from the cluster control that we already created, or we can create it manually. And just as on our panel, we can populate this by selecting our data elements. The cluster order is analogous to the index of elements in an array. If you wire two clusters together, corresponding elements, determined by the cluster order, must have compatible data types. The default cluster order corresponds to the order in which you added each element to the cluster. If you delete an element, the order adjusts automatically. You can change the cluster order by modifying the data items list in the configuration pane. When you create a cluster, the data elements will probably not be evenly spaced or aligned in the cluster. Use the Arrange drop-down in the configuration pane to automatically resize and/or rearrange the cluster. Click each box to learn more about how LabVIEW NXG can automatically arrange your clusters. Now that you know how to create and configure a cluster, we will discuss how you can programmatically read and modify cluster data. Use the Cluster Properties node to read and write cluster data. Once you place the Cluster Properties node onto your diagram, you will need to configure it to either read or write data. In this example, we read the current and maximum temperature values from the Weather Data In cluster and compare them. We then write warning data to the Weather Data Out cluster. Now let's explore how we can read and write cluster data. In this example, we took several controls and indicators and combined them into the Weather Data cluster. We placed two instances of that cluster onto our panel, the Weather Data In control and the Weather Data Out indicator. Now let's take a look at our diagram. First, I'm going to give myself a little bit more room, so I'm going to select View, Show Hide Panes. And now I'm going to stretch this to give myself a little bit more room to work. From the Unplaced Items tray, I'm going to place the Weather Data In cluster. Now I'm going to place an instance of Cluster Properties. When we wire Cluster Properties, that's when we're able to select which cluster values we want to read. I'm going to stretch this, and we're going to read the current temperature, the maximum temperature, and the minimum temperature. Now I'm going to wire this to our diagram. Now let's take a look at how we can write data back into this cluster. I'm going to place another instance of the Cluster Properties. From here, I'm going to wire the cluster across. Then I'm going to specify which values I want to write. I want to write warning, and I want to write warning text. By default, it's showing as read. To change that, I can right-click on here and select Set All to Write. Now I can wire warning and warning text. Now I can place an instance of the Weather Data Out cluster and wire that. You can also programmatically create a cluster by using the Build Cluster node. Now that you are familiar with clusters and how to use them, we will take a closer look at a cluster that you have already used, the error cluster. Error clusters, by definition, contain 3 elements. Click each element to learn more about it. Unlike other clusters, if you want to read or write error cluster data, you should not use the Cluster Properties node. Instead, use the specific functions that LabVIEW NXG provides in the Error Palette category. Another special use case for clusters involves plotting data to charts and graphs. You may encounter a situation in which you want to include multiple plots on your chart. To do this, use a Build Cluster node to combine a single Y value for each plot into a cluster, which you can then plot to the chart. Note that this technique only works for charts. If you want to combine plots for a graph, you will need to use the Build Array node. While charts and graphs will probably satisfy most of your needs, you may encounter situations where you need a different option. To create an XY plot, use the Build Cluster function to combine the X and Y arrays into a cluster which you can then plot to the XY graph. Click the link to learn more about how to wire MultiPlot data to charts and graphs. Now we will explore different ways to present arrays of cluster data on your panels. Now let's explore two approaches for displaying arrays of cluster data. Here we see a simple one-dimensional array of weather data clusters. Let's take a look at the diagram to see how this is generated. We have several instances of the Acquire Weather Data VI, and we are taking the cluster outputs and building an array out of them. Let's go back to our panel. This approach for displaying arrays of cluster data works, but it eats up a lot of real estate on our panel. Let's explore another approach. Here we're going to place an instance of a data grid. When you place the data grid, you'll want to be sure to go to the configuration pane and specify that you want it to auto-adapt. This means that when you wire something to the data grid, the various values and labels will automatically adapt. Let's go to our diagram. We go to the Unplaced Items tray and place an instance of the data grid and wire it. Now let's go back to our panel. Here we can see that the data types and some of the labels automatically adapted. To continue configuring, let's go to the Layout and specify the appropriate labels for the different numeric values. Note that within the layout, you can configure the data types. For example, you can change this Boolean into an LED instead of a checkbox. Now let's resize the data grid. If we scroll a little further down, we see that for the column width we can specify whether we want to stretch a single column or all columns when we resize. So first we'll stretch and resize the current temperature, then max temperature, min temperature, warning, and warning text. Now let's try running the VI. Here we see that by using the data grid, we're able to view the same amount of information but use a lot less space on our panel. As you develop more complex applications, you may find yourself in situations where you want to place instances of a complex cluster in multiple locations. This can introduce challenges if you ever need to modify the contents of that cluster. When creating a cluster, you should almost always turn that cluster into a G-type. You will learn more about G-types in the Propagate Data Type Changes Using G-types lesson. You have completed this lesson. Here's a summary of what you learned.